And that way, once 3 o'clock comes, we can just roll right into it.
Okay, no problem. Dale, will you monitor the chat for me?
Sure, I will.
I'll go ahead and put myself on mute until 2.
All right, you're hearing me, right, Keisha?
I'm hearing you. I just closed my PowerPoint by mistake. Give me 2 seconds.
All right, so I'm going to mute now and I'll monitor the chat.
Okay.
Damn, last session started.
Hi, everybody. We're just waiting until 3 o'clock on the dot, so that will give others a chance to come on to the session. So we'll be starting in a couple of minutes.
Okay, everyone. I think it's safe for me to start the introductions now, so that we can lead into the session at 2. My name is Akua Walters. I'm one of the co-founders of Hacker Hostel. Today we have 2 representatives of Teleios that will be leading our introductory session on software quality testing, and how do we know that we've built actual working software. We have Dale Wilson, and I do forget his counterpart's name, but she will introduce herself in due course, I am sure. But I'll go ahead and hand over the session to Teleios. And have a great time, guys. And please do not forget to mute yourselves once you get into the room. Dale?
Hello. Good afternoon, everyone. I'm just doing a sound check. Can everyone hear me clearly? You can just type in the chat. Okay, great. So good afternoon, everyone. I know you all came out for a session called Unit Testing, and on your screen right now, you should be seeing what is working, an introductory session on software quality testing and how we know we've built working software. So I will go right ahead into the introduction as to who I am. My name is Keisha Mark-Peters. I'm the manager of Software as a Service operations at Teleios Systems Limited. So let me tell you a little bit about Teleios. We have been in existence since 1997, and we are a leader in cloud, mobile, and automation services. Our tagline is, we build software to run the world. So that's a grand claim. So with that grand claim, you would have a group entitled Software as a Service Operations. So I think and I hope that everyone knows what software as a service is. So I will just explain that software that is built and offered as a cloud solution. So a grand example that everyone may know, Office 365 is software as a service. It's an online version of Office online that anyone could use, but it's online on the internet. So our main cloud offering, one of our main cloud offerings is QuickWorks Cloud, where our users can log into QuickWorks and build workflows using our technology that we built right here in Trinidad and Tobago. So what is the Software as a Service Operations Group do? We handle all the after needs of the software that is deployed for our customers. So we are divided into three groups. We have quality assurance, we have operations or the DevOps team, and we have help desk and customer care. So we handle all the after development work that our software needs. So why did I name the session, What is Working? So let me talk about how I got to here, my journey. So I started in Teleios as a developer. Then I kind of moved towards working as an analyst. So I would go out to the clients, get requirements. This is with my developer knowledge. Then at some point, I was asked, Keisha, would you mind testing this? So I started off as a tester, and then I became quality assurance manager. And now I'm overseeing the entire range of after software care. And that has given me quite an insight into how we build software and what is working. So I'm going to show, maybe I'm referring to myself here with my next two slides, but I can make this grand statement that I tend to know how developers think. How do developers think about quality and testing? I would say that developers generally don't care. All devs, you can correct me in the chat if I'm wrong. If you'll constantly think about the customer and you'll think about how my code is going to affect them, go ahead and correct me. I will look out for those comments. However, I know when I have code to write, I want to jump into it one time. So this is the first comic. You jump into the code, you try to do it as fast as possible, and then you fall off into the bug cliff. The bugs wait, just waiting for you at the bottom. Then you think that your code is just so grand, and you know what I'm doing, I'm using the best of everything, I'm the best architecture, I'm writing the best piece of software, my code is in fact is unbreakable. You go in, you jump in at the last minute, you do or replace all. Okay, yeah, I had a great day. But, you created a monster who waited on you. You don't know that you broke the build. And, like in Teleios here, and I'm talking from experience, everything I'm saying is from experience. When we first really introduced testing as a part of our process, developers were like, when you went to developer and say, hey, this is a bug, the resistance that you got was so great. I've had many countless arguments saying, but this is a bug because of whatever reason. And eventually everybody, I would say, fell in line and everybody started to think more along the lines of quality. And that is why I am here sharing this beyond just unit testing today. I want to talk about quality, what is software quality, how do we know things are working, and what is testing. So any comments, questions so far?
No, it looks like we're good.
Okay, great, no problem. I saw somebody from when we learned about software engineering. Well, I remember when I did software engineering, my little testing unit was real small. Okay, so let me continue. All right, okay, the orange bright. So whose business is software quality? So I put some definitions here. Quality software is reasonably bug or defect-free, delivered on time, within budget, meets requirements and or expectations, and is maintainable. This is a lot of things standards to live up to. The ISO standard for quality defines quality as the totality of features and characteristics of a product or service that bears its ability to satisfy stated or implied needs. So just from these definitions here, we can see that the entire team's responsibility to look after quality. The entire team needs to work together to build quality software. So I know developers who have said, oh, the requirements are not my business, or I just build what they tell me to build. Or, when you go to them with a bug, I'm not thinking about the customer. Or when even as a tester going to the or when somebody comes to the tester to say, oh, did you test this properly? And everyone has this, I want to stay in my silo. However, testing and quality is everyone's business. Because imagine you use the best coding techniques, you use the latest pattern, the latest tools, and you build this thing you think is totally fantastic. And when you give it to the client, they say, but this is not what I wanted. And it just sits down there and no one uses it. I don't think anybody would really like that experience. And that is not working software. Software that does not deliver what it says it's going to is not working software. So we need to think about things like maintainability, how it's going to meet expectations, and we need to deliver it on time and within budget and bug-free. So this is a diagram that I use internally a lot. So I do a lot of metrics to the teams to present and show how we are working. And this is something I remind people of time and time again. So delivering poor quality software has a cost. And I'm not just talking a monetary cost, I'm also talking a time cost. So yet bugs can be found at all stages of the software development lifecycle. And according to how far down you go, it can be costly to fix. So building software can be likened to building a house. The more you get into building, imagine you just finish paint and you realize something wrong with the electrical system in the house. And you have to go now and start to break down the walls. How expensive is that? It is expensive to fix an earlier issue. So if you have your proper plans, it is much easier to fix your issues earlier, to find them out earlier and fix them earlier. Rework is expensive. So this is what this diagram is basically saying. It's cheaper to find a bug or an issue in requirements than it is to find in live production. And also another cost in live production is that you're going to look unstable. Your client's going to complain and they're going to have a poor view of what you're delivering. Somebody needs to mute, hello? So a simple example. So imagine that, okay, this is very, very simple, very trivial. You read the requirements, you give it a read through. You decided, okay, I'm going to implement this with a drop down as opposed to a radio button. As a developer, it doesn't really matter to you because it's a choice field. But to the customer, this little insignificant quote unquote difference, that may matter, right? So you pass it on to production. And then when the customer sees that, that affects what they thought they were going to get. And they complain. So now you have to, and you already moved on to develop some other new feature. So you now have to stop your development on this new feature, go back, reopen that code, fix that code, make the change that they want, put it back, get it tested, get it redeployed, put it back into production. And then by touching that old code now, that you may have forgotten some things about it, you could implement more issues right there and then. So again, rework is expensive. I'm just going to stop to check the comments. Okay, my next slide. All right, so how do we find bugs? One easy answer, through software testing. So as I said, when we started to really put testing as part of our process, the resistance, I mean, we're talking real life examples here, the resistance, I've had many an argument with developers, and I was a developer first, saying this is not what the customer wants. This is not what we're developing. And we had to get mediation from the product manager to say, hey, this is what, or this is what I think, or, so there's a lot of compromise across the board, a lot of referring, going back to the customer, etc. And as a developer, we tend to say, no, testing, that's for the testers. They just go and step everything manually. And testing is a lot more than that. We all have a part to play. So I have a general definition for a bug. A bug is an error, flaw, or failure that causes it to produce an incorrect or unexpected result, or to behave in unintended ways. So simple bugs, a spelling error, that is a bug. We'll think that is so simple, but it's a bug. Your page and you have non-functioning links. The big things as your system crashing because you have unexpected inputs. Somebody entered $sign into a text box and you didn't think to check for characters, for example. Another bug is slow performing pages. Your website taking forever to load. People are going to get fed up and leave. No one is going to use what you built, right? Or the system, what you built, is not what the customer wants. All of these things, from big to small, are considered bugs, right? So I have here in my notes, I want to dispel, okay, so as I'm starting here, that no one team can find every single bug. It is sad. I have been asked in the past, say a bug slips through QA, and then come and ask why QA didn't find that bug. Listen to me, I wanted to die, mortified. Anytime a customer found a bug that I did not find, I was mortified. But all of that helps with learning, getting better tested. And it taught me that I have to get everybody to see bugs differently, to see what we build in differently. Okay, so I'm just going to go through right now, it's theoretical, some testing classifications, right? And before I get into the types of testing, so when I go into the types of testing, we'll classify the tests and we'll move on from there. So we have white box testing. So this is usually done by developers. So this is when the tester usually knows the internal structure of what they are building. So you as the developer, these are the methods I'm building, this is the frameworks, these are the frameworks I'm using. So you are best able to test using white box testing. So you could find poorly structured code parts, test conditional loops, look for expected outputs, try unexpected inputs. Black box testing is when you don't know the methods or what is in the software, and you just test in the requirements. So you will verify that the software meets the user needs. Then we have functional and non-functional testing. Functional testing verifies each aspect of the software, again, aligns. So we have a lot of overlap here. with the requirement specifications. So it involves so as I said, anytime I think with requirements, that doesn't mean yet you really know, you don't have to know what's going on inside. So again, some black box testing. So you're not really concerned with the source code. Then you have non-functional testing. So you'll got things like performance, excuse me, load testing, usability testing, reliability testing. So example, as a developer, you would think, oh, you're not going to think about usability. You're not going to think about that customer who is actually using it and might have to drag something from the upper left corner of the screen to the lower right corner, and how hard that may be for them to do, you know? So non-functional testing looks at these. Am I going too fast? Okay. Great. All right, and then we have manual testing and automated testing. So manual testing is you basically going through the software and you're executing the steps and you're executing test steps manually. The tester will check the essential features of the software without any automation software testing tools. Automated testing, the testers will write code or test scripts to automate test execution. Hold on, give me a second here. Sorry about that. Write test scripts to automate test execution to validate the software. The goal is to complete test execution in the least amount of time. You will require some manual effort to create initial test scripts, and it requires maintenance. Every time you make a change, you will need to go and change the automated test scripts. The advantages of automated testing is that it allows for repetitive tasks to be, or repetitive thing to be tested over and over again. It allows for a lot of repetition, and it tests regression. So regression is basically you created this method, or you created something, a feature, maybe like some months ago, but you continually building. And every time you build or you make a change, you don't have to think about that test again, because you already wrote a test that will test that one. Make sure that no changes you're writing affecting the older parts of the system. And testing actually is a good combination. We should test with both a combination of manual and automated tests. So when we testing overall, not everything. So a lot of people think testing is not testing if everything is not automated. But the human interaction with the system, in terms of things like usability or performance, for example, or even function, there are some things that you just not want to get the same with the experience and the eyes of a tester. Okay, so with those classifications, we go into the different types of testing. So if you remember our pyramid, it costs us $0 basically to find bugs in the requirements. And I found this metric that I found very, very interesting. 50% of bugs are introduced during the requirements and design phase. And that is due to misunderstanding and ambiguous and incomplete requirements. So I know everybody here is on teams, and on the team, how many people just read through the requirements once or twice, didn't didn't ask any questions, or to the persons, or say, what about, or I wonder if this is what they really want, and they already start to write code. I'm going to check the chat to see how many hands go up. How many people start to write code already? Nobody. Okay, that's good. All right, somebody saying that they need access to the customer, so they haven't started to code yet. Somebody said, I find that strange, right? So I know as a dev, you read something, you don't start to think about, oh, I could use a queue for this. I could put this here, we'll put this, we got this to the cloud. We will do so. You then start to get excited about architecture and stuff. And you don't really think, you're not thinking about, is this what I think they want, what they really want? So requirements testing can be classed as black box because you know the requirements. It's functional. You're checking out the functional. You're checking the functionality, and it can be manual. It's mostly done manually, right? But it can be done so early in the process, whereby you have early review meetings. You do some use case designs. You have analysis, and you include everybody in the team. So here, when we get requirements, the analysts, QA, the software architects will look at the requirements and it's like, what are they really asking? What it is they really want us to build? And we will send back questions to the customer through the analyst. Is this really what you want? Is this how you want it? Questions to really flesh out their requirements, because we have gotten burnt in the past. And when we don't do that, we end up building what the client is like, oh, well, yeah, it's nice, but it's not really what we wanted. Right? So this kind of sit down usually results in questions for and clarifications from the customers. So we need to not do interpretive analysis and think, oh, well, I go and give them what I think they want. Right? So at this point, I will just mention something called BDD. So it's behavioral. Hold on, it just went out of my head. Right, behavior-driven development. So that is where you have three amigos, which is the analyst, the tester, and the dev. They sit down together to really thrash through the requirements. That you can have further reading on that, but I'm not going to go through that. That's a deep rabbit hole for itself. But BDD has its own automation tools. Right? So then we have unit testing. So unit testing, after you do requirements testing, you do your design. So when the code is actually being built, you can do unit testing. So unit testing involves individual testable units of code are tested to ensure that they perform as designed. This can be classed as automated, functional, and white box type of testing. I'm sorry. Because you as a developer, the one writing it, typically done by the developer, the code authors, you are the one writing the code. So you know what this piece of code is supposed to do. And is used in regression testing as ensuring changes and additions hasn't broken existing functionality. So for example, you make a change today, as I said, and you want to make sure that this change hasn't affected anything else. You will run your unit tests to make sure that everything else works as before. There are schools of thinking that among developers who think that tests should be written before you write any piece of production code. Meaning you should have all your tests and then, start to make, and all your tests should fail in the first part, and then you should start to write code to make every test pass. And that is called TDD. So we had BDD for behavior-driven development, and then we have TDD, test-driven development. So that's another rabbit hole. I'll be doing a small unit test demo where I'll be writing my tests and making my code, then making my test part by actually writing code, but I will come a little later on, right? So the advantages of unit testing, you spend less time performing functional tests. Because when you're performing functional tests, it's like you have to actually open the software, go through it. Whereas while you're writing, having unit tests, you're testing individual pieces of code, you're testing your methods, right? And every time you could just, because it has to be, because you're writing code, you're going to be running this time and time again. So it's going to be fast. It gives you that regression protection, and it's executable documentation, because you are basically saying, okay, this test is this method, and I'm looking for this. So at the same time, your code going to have some documentation. And I know for a fact documentation is where a lot of software teams fall down. And that is part of maintainability, because in the definition that we had in the first slide or the second slide, it said that working software, quality software is maintainable software. Sometimes you write something 5 years ago, 6 years ago, and then a client using it all these years, and then something stops working. And then you go, how does things work again? Because we have no documentation. We don't know what the code is supposed to do. So unit testing provides us with executable documentation, right? And regression testing is especially important in agile or iterative software development life cycles, because you're just building small pieces of code at a time. And every time you run, you want what you built before to work. So once that test passes, you're okay, you're good to go, you can continue. Right? What slide is next? Okay, so I just covered 2 other pieces of types of software testing that we use here regularly a lot. So smoke testing. So when in QA, when we get a code build from developer, we run a smoke test on it. And that is to ensure that the key features of the system work. Before we get into the nitty-gritty and test every single feature and run a set of tests, we run a smoke test. So think about, I read somewhere that this is where it got its name from, that, plumbers in a house, they're building pipes and they will run smoke through the pipes to make sure there are no leaks. So you're just making sure that the key features of the system works before testing in depth, right? It's black box, it's functional, and can either be manual or automated. So an example is, for example, you get a new build for the team is building a shopping application. Release 1 was good. You could have put things in the cart. You could have say order. Release 2, they introduced some new features. You could zoom into the item you want to buy, then put it in the cart, and then order. But on build 3, where they introduce something else, all of a sudden you can't put it in the cart. That is your smoke test right there. Before you introduce a new feature, you make sure some of the old features still working. The key features. If you build a shopping app and you can't put it in the cart, okay, send it back one time. This thing not working, right? That's smoke testing. And some non-functional tests, types of testing, performance and load. So your performance, you're testing to make sure that the system is responsive, it's stable, it's reliable. Basically testing the speed of your system. And load testing, making sure that things perform well under peak and expected load conditions. You don't want, when you bring out a new site, selling some hot ticket item and your site crash when everybody come to check it out one time, which happens a lot like on gaming sites, on I think I heard that the tickets for the latest Avengers that's coming out this month came out, and the movie, I think it was Movie Town, one of those sites crashed. I could be wrong. So that's where you perform load testing and performance testing. So it's non-functional, usually automated, and can be performed under white or black box conditions. So I think it was, someone was asking about, I'm just checking the chat again. About actually doing the test. So I'm just going to give a short example here about how do we know what to test, because you could test so many things. And as I said earlier, I have been asked in the past when a client found a bug, how QA didn't find that. And as again, I said I was mortified. So you have to know what to test. You have to know the risk areas of what you are building. So there are techniques. So you will build like a test case is the piece of that is what holds all these steps to your test, right? And how you have different testing techniques to build test cases. So I just have one example here. There are many techniques. This is one I've used recently, and it's called equivalence class partitioning. So it's a requirements-based technique because you know what it is what you expect, you know what you're looking at. And I have a simple example. So basically, you know what the requirement is, and you're going to divide the inputs or the requirement into groups. So every group that fits into, when I get into the example, it'll be easier to understand. So the example is a text box should only accept numbers 1 to 10 inclusive. So let's partition this into ranges. So partition or range 1, obviously, is 1 to 10, right? So the text box is only accepting items 1 to 10. Any input from this range should yield a success message, right? Partition 2, anything less than 1, inclusive of 0, should yield an error. Partition 3 or range 3, anything greater than 10, we know should yield an error. And we know blank inputs should yield an error, but not fail. So when you have inputs, so basically that's what equivalence class partitioning is. You know your inputs, okay? So you have to figure out what's going to fail, what's going to pass based on your ranges. You're supposed to separate your input into ranges. Am I clear? Did the example make sense? Talk to me in the chat. Okay, Shaquille says it makes sense, right? So this is just one example of how to come up with test cases, how to know what to test. You have to know your risk areas. You have to know where the vulnerable areas, where people could take advantage of. And this is all contextual on what you're building. If you know you're building a game, you know, okay, load and performance going to be risk areas for me, right? If you build in medical software, for example, you have to know what are the risk areas there. Building financial software, you have to know, okay, security is something that I really need to pay attention to here, right? So other techniques include, well, boundary value analysis. And in this simple example, we can look at the boundaries. 0 is a boundary. So when we create a test, we're going to put in, you can put in the boundaries, okay? 0, everything after 0 or 0 will give this result. Everything between 1 and 10 will give this result. So I could test 10. I could test 1. Everything more than 10 will give this result. So I could test 11.
Because they have the least talent. Although you can inherit them from the city of San Antonio.
Hello?
But
hey, I'm talking. Okay. So there's also, I want to mention on this slide here, in terms of testing techniques, one testing technique that you wouldn't think is important, but it's called an experience-based technique, and it depends on the skill and knowledge of the tester, and it's called exploratory testing. And I think everybody, whether a tester or not, has done exploratory testing. For example, you go on a new website, and you didn't read anything about it, but you just start to click. I wonder what this do, boy, and you start to click. I wonder how that is exploratory testing. But obviously, when you're testing in a work scenario, you're testing based on knowledge of, okay, I don't know exactly what it's built. I don't know exactly how it's built, but I know, okay, this is a piece of financial software. Let me try to compromise the security. Again, it's based on your experience. Let me try to load this. Let me try to inject some SQL. So what you're testing, again, the context of what you're testing, the experience, your knowledge, going to help in testing. So, okay, at this point, I'm going to go into the building a unit test because I know a lot of people on the call are developers. So I'm just kind of going to demonstrate one and share my code for it. So let me just check the chat before I do. Right, okay. All right, so All right, the anatomy of a unit test. So let me see by a show of hands how many people here ever, well, at least in chat, wrote unit tests before. Okay, no one. All right, so basically, okay, a unit test is very simple to write. You are the one, you know your method, right? So you're just going to write a test for your method. And you're following these simple steps to write a unit test. Arrange, so you create the objects you require, you act, you're just calling your method on the test, and you're making a assert. Whether the actual value, the actual result from the method equals what you expect, right? So what we're going to work on, we're going to write a method that determines whether the input is a palindrome. And I'm sure everyone has probably done this in school, has done this method. Maybe not with writing test fits, right? So let's apply, let's think about equivalence class partitioning. So thinking about the different inputs that this method should take. So let's think about the ranges, right? So it must accept a palindrome. It must, if you enter a null string, it should be able to handle that. It should probably return false. If you enter a word with multiple cases in it, it should still return true. If you put punctuation in a sentence, but the words in the sentence can be considered a palindrome, it can return true, but it should return false for words that are not palindromes. I didn't put this up on a slide, maybe I should. So in the slide deck after, I will add it. All right, so let me now share, I'll stop sharing my screen for a while and bring up Visual Studio. Oh, just now. Okay. Is everybody seeing my screen? Okay, so at Teleios, we use a Visual Studio for a lot of our development, and Visual Studio comes with its built-in unit test framework, right? So I believe this is MS Test. So I already built my class and I started to write my, oh, sorry, hold on 2 seconds. Okay. I already started to write my method. It's palindrome. It returns a bool and it accepts a string value. So one of the things we said is that it should return true for a string, right? So I'm going to go to my test file. Sorry. I'm going to create a test method, and when you are writing unit tests, you follow, there is a naming pattern that you follow, and one of them you would follow the naming pattern. Let me just write it here as a comment. So I'm going to follow method name, then see what is my expected behavior, and then what is the state that is under test, okay? So this test I'm writing is palindrome my expected behavior, I wanted to return true for single palindrome word, sorry. Right? So from these slides, we saw that we have to, just give me a second to drink some water. The anatomy, so let me just write, we're going to arrange act, then assert. So we're going to arrange our variables, right? So basically, I'm going to have a test string in my test. So I wanted to return true for a palindrome. So a simple palindrome is wow, right? I'm going to initialize a palindrome object. Then I'm going to act. All I'm going to do here is call my method. So I'm going to pass the value, the string that I want it to be. So it's going to pass this into my method to see if it's a palindrome or not. And then I want it to return, so I'm going to see if it's true. So we know that wow is a palindrome, right? I'm going to assert that if it's true. And simple, a very simple unit test. However, if you go back to my code, I haven't really implemented anything yet. I said it's going to return false. So my unit test should fail, right? So let's just run. I saw some people asking in the chat. Yes, this is C#. Right. Okay. Right, so we see it fails. It's supposed to fail. So remember I talked about TDD, where you write a test, you test first and then start to make your code pass based on the test you wrote, right? So I'm going to start to implement my palindrome. So I'm going to say, I'm going to check to see if it's reversed. I have my code written already. I came prepared. So I decided to just type it over. I'm like, meh. All right, basically, I'm just going to reverse the string and then compare the values, right? See if reversed is equal to value. Why are you quarreling? Yeah. Oh, sorry, I used the wrong equal. Nice. Let's run it again. It should pass now because I implemented it. Right, so it should pass now. So another case that we said was that it should, let's go back to my test. I'm going to write another unit test. That my test should, my method should accept nulls and deal with nulls and return false for nulls, right? So again, I could simply, so this one is going to check for null strings. say, okay, so I'm going to cheat. Right, so I'm going to say returns false for null strings, right? Again, method name, the behavior, and the state under test, right? So again, so my value is going to be null. Again, simple again, I'm just calling the method, and I'm going to say I'm expecting it to be false. So I have to change my set. Okay. So now we go back to our method, and all we do here in our method is say, so we have to make our, so if we run it, let me run it first to make sure that we see that that fails, that test failed. Oh, shoot. You know what I didn't do? I didn't put test method. Okay. That's how it recognizes, the framework recognizes that it's a test method, right? So it should fail because my code doesn't deal with it. So if return false, and I can continue building out this method with more tests and make the test fail, and then go back in my method and make it pass. Right, so let me pause here for any questions. Is this understandable? Was this code demo helpful? It's 3:48. I had some more methods to share, but yeah. So, okay, great. So yeah, so you could just continue. So let me just give a paste of some of the, is there a more general, this is the same, no. All unit tests follow the same structure. Arrange, let's go back to the test. Arrange, act, and assert. All unit tests follow that structure. You start to write your test. So don't think about the language. The language I'm using is inconsequential. Think about arrange, act, and assert. Think about how you're naming your method, because remember we said it's documentation. It's executable documentation. And because every time you write new code, you all tests supposed to pass, and you need to know what is passing. And when you're writing a test, arrange, act, and assert. Right, so this is a good question. I found that writing unit tests while developing significantly reduces development speed. How do you find the sweet spot? Honestly, we're still struggling to find the sweet spot. So here in Teleios, so I have slides like to talk about how we really test in Teleios, and this was one of them. So right now, the QA team does not accept any code from the developers unless there are unit tests. Yes, it slows down development, but in the long run, you see the benefit in terms of regression issues. So when a developer checks in code, the check-in automatically triggers all the unit tests to be run. So if any of the tests fail, you automatically get a bug straight to your email saying, hey, this test failed. And you have to go and fix that test because your code, your change broke the test. And that is a way of maintaining quality. So again, to remember the graphic I shared in the beginning, where, you know, as a developer, we just want to go fast. You know, we don't want to be safe. We're not thinking about, okay, is this going to be maintainable for the long run? We just want to go fast. So I don't know if there's really a sweet spot, you know, because we struggle with it too. And especially when you have client demands, clients breathing down your neck, clients saying, oh, well, I want this now. You know, you're trying to meet deadlines. It's a struggle to maintain that. But in the end, you want that maintainable code. You want to be able to deal with regression issues easier. You want to have the tests. That's a real good question. I wish I could give you a better answer. Any more questions? So you can write your own unit test as well. Yeah, basically, okay, yes, basically we should be flexible. Any more questions? So in that scenario, how do you go about indicating how much time is needed for testing? Okay, so further to how we develop here, so we do an iterative software development lifecycle. So we use Agile and Scrum, and we develop in week sprints. So the testers, so our test team is part of the sprint, and you see it's all in the planning as well. So we break work up into week-long amounts. So you're not supposed to try, so using this agile form of development, you're not going to try to pack too much work in the sprint. You're going to, along with the product manager, the analyst, the tester, everybody is going to sit down and say, okay, we think this is the amount of work that can be covered in this week, inclusive of tests. So it's all in the planning. So you know, I have to write these tests, I have to write my code, and I have to be able to leave some time. So, but I don't want to send it to testing on the last day of the sprint for the tester to now start to do work, right? Because the tester, if you don't send it before, the tester is not tested, is not going to be done. If you have bugs, the tester is not going to mark it as done. If you don't have tests, the tester is not going to mark it as done. So yes, we may impose a lot of restrictions on the code going to production, but it's all in the name of quality, it's all in the name of having working software that the client is going to use, meeting the requirements, not creating monsters down the road. And yes, we want to get things faster, but from experience, the monsters down the road having to do rework is harder to fight than doing it right the first time. So it's all in the planning. Anyone else? Can unit testing be performed manually, or should it? I would say my advice is to do it automatically, because you want to, so I saw this graphic sometime that the most amount of tests you should have in any project is your unit tests. You should have a huge amount of unit tests, because that's where your code change is going to be in your methods, and you want to make sure that these methods are running and passing over and over and over again. And doing that manually, doing each thing manually, is going to be really tedious, as opposed to, you know, if you do functional testing manually, yes, it's going to be more time consuming. However, I would say to keep a unit test automatic and using frameworks. So like there's JUnit, NUnit, you know, there are a lot of free tools out there to help. Do you develop test plans for UI and UX as well? So we have a design team who in Teleios, so they will look at the requirements and come up with a design for the product beforehand. and who the developer who's actually building UI and UX, they follow what they say to do, right? They follow what is given to them. And so that's kind of like a visual testing, right? So that's manual. QA will sit with the what was given to them, and match it back to see, okay, well, you didn't use this font here, you didn't do this out of place, this is wrong pixels, etc., etc. So it's not to say that we have a test plan specifically fit, but if there's design work, again, it fits into our sprint and it is tested. Are we getting any sessions on UX? I am unable to answer that. I don't know, but I think I saw something on design at some point.
I am unsure of that. I'll have to check the schedule. Though I do see Winston online. Could you quickly see whether?
I can speak to that, Dale. We are going to be covering design thinking as a user-centered design approach, and we'll actually be going through three 1-hour sessions of that. So anywhere that you see user-centered design is going to be speaking in broad terms about UX, and then going more specific to the problem sets that we'll be covering. So you will see that. Does that answer your question? I'm seeing great. Thank you. Okay. Cool. Back over to you.
Okay. So I guess it's 3:58. If no one has any more questions, I just want to wrap up and say that, to remind everybody that working software that the customer wants to use is the goal, not just writing with the latest tools, not just writing the latest architecture using we can get caught up into the best things. Oh, this is so fantastic. To think beyond there. I don't know if you all see my screen. So I found this. I like monkeyuser.com. I follow them on Instagram, and I'm always laughing at their posts because it's so real life and because I live it. So, the guy's like, oh, you're going to love this state-of-the-art architecture. Everything is reusable. And the guy's like, what about the product? And the product is a fail because nobody using it. So as you go forward into your projects, keep that in mind and keep using and keep testing. Think about quality, think about testing, think beyond the code. Okay, so I'd like to thank everybody for this afternoon, for paying attention and being such a lovely audience. And I hope you have a greater appreciation for testing.
All right, Keisha, thank you very much. I think this was an excellent session. I hope everyone agrees. I do want to remind you to fill out the survey. There's a link to it in the chat, so please fill it out because we do want to track these sessions and your responses to it so that we can keep getting better. I would ask Keisha to do one thing. I believe your camera was off while you were doing your presentation. I just wanted to have everybody get a look at you.
Oh, snap. Okay.
Yeah.
Hi, let me fix. I'm sitting in my office here. Hello, everybody.
All right, everybody say hi to Keisha.
Hi.
So, excellent, Keisha. This was well done. So guys, I think that's it for the sessions for today. I don't know if Akua or Winston has anything to wrap up, but just again to remind you, please fill out the survey and think about what you need to do to get your code working, not just your code, but the solution working, because at the end of the day, that is what we want. To have something that is deployable and something that is usable and something that the client is satisfied with, not just fancy code. So make sure you have testing and quality assurance somewhere inside of your plans as you move forward with your various projects. All right, Winston, Akua, anything to add? Over to you.
So thank you guys for leading the session. Tomorrow, well, let me say Friday, the next session will be at 9 a.m. Trinidad time, and that's starting with the Y. So until then, guys, follow the material, review the materials that we've done so far, look at the videos. This video will be up. This video will be up upon request. And thank you so much for attending. Take care.
All right, bye everybody.
Bye, everybody.